Imagine a universe where everything is like a mosaic, built from tiny indivisible tiles. In this world, there are no smooth, continuous lines, just discrete steps from one point to the next. This is the essence of a quantized universe, a place where even space itself is divided into the smallest possible units, like Planck lengths, far tinier than anything we can currently observe. In this reality, our familiar number system, with its infinite continuum of values between any 2 points, would be fundamentally different. Irrational numbers, those fascinating entities like pi and the square root of 2 that cannot be expressed as simple fractions, would simply cease to exist. Think about measuring the diagonal of a square with sides of 1 unit each. In our continuous world, this diagonal would be the square root of 2, an irrational number with an infinite, non-repeating decimal representation. But in our quantized world, the diagonal would have to land on one of our discrete steps, forcing it to be represented by a rational number, a simple fraction. Let's consider the fate of pi, that celebrated constant representing the ratio of a circle's circumference to its diameter. In our familiar world, pi is an irrational number, meaning its decimal representation goes on forever without repeating. In our quantized universe, pi would face a crisis of identity. Imagine trying to draw a circle using only our discrete steps. The curve of the circle would become a series of tiny, straight lines, always approximating the true circle but never quite reaching it. This means that pi, in this quantized world, would have to be approximated by a rational number, a number with a finite decimal representation. We would lose the elegance and precision of pi as we know it, and with it, our ability to describe circles with perfect accuracy. The very concept of infinity, a cornerstone of mathematics, would undergo a radical transformation in a quantized universe. Consider the set of all numbers between 0 and 1. In our continuous world, this set is infinite, containing an uncountable number of both rational and irrational numbers. However, in our world of discrete steps, this interval would become finite. Since there's a minimum distance between any 2 points, the number of points we could fit between 0 and 1, while potentially large, would be limited. This challenges the notion of Cantor's infinities, which describe different sizes of infinite sets. In our quantized world, the distinction between countable and uncountable infinities might disappear, fundamentally altering our understanding of the infinite. A quantized universe devoid of irrational numbers would demand a complete reimagining of mathematics as we know it. Calculus, heavily reliant on the concept of infinitesimals and the smooth, continuous nature of functions, would need to be reformulated. Fields like topology, which explore the properties of shapes that remain constant under continuous deformations, would need to adapt to a world where continuity is no longer a fundamental principle. While we might lose the elegance and power of some mathematical tools, this new reality could open doors to entirely new mathematical frontiers. Perhaps a new form of calculus would emerge, one based on discrete differences rather than infinitesimals. The absence of irrational numbers would undoubtedly make our universe a much stranger place, challenging our fundamental understanding of mathematics and the very fabric of reality. It's a thought-provoking reminder that our current mathematical framework, as powerful as it is, might be just one way of describing the universe, and that other, equally valid and perhaps even more profound, mathematical systems could exist, waiting to be discovered.